In this video, we will discuss calculating the arc measure and central angle measure. Now, the first thing is that it tells us that the measure of an arc is equal to the measure of its corresponding central angle. So, for example, the measure of this angle is the same as the arc. It also tells us that congruent central angles intercept congruent arcs, and congruent arcs intercept congruent angles. So, meaning if these angles are these arcs are congruent, so they're both y, then these angles are congruent. So they are both y. The bottom theorem tells us that the total measure of a circle is 360, which means that all angles or arcs in a circle add to equal 360 degrees. So for example, in terms of what we have here, we're given that this arc has a measure of 87 degrees. And the question is asking for this central angle. Now, because this central angle intercepts the arc, this means that this angle is 87. So the measure of the central angle is 87 degrees. Similarly, the next question gives us that the measure of the angle is 63 degrees. So the angle is 63. The arc that's intercepted by the angle is shown right here. So this arc is also 63 degrees. So the arc has a measure of 63 degrees. Now for the next example, we have our angle. Our central angle is 95. And the arc it intercepts is this arc right here. So it's 95 degrees. So the measure of arc AB equals 95 degrees. Now the second part of the question is asking for the measure of arc ACB, which is referring to we would start at A, go around the circle, through C, and over to B. We don't know what that angle is, or that arc is. However, what we do know is all the arcs in a circle add to 360. So we could say that x plus 95 should equal 360. So if we solve and you subtract 95 from both sides, 360 minus 95 gives us that x equals 265. So the measure of that arc is 265. So this angle here has a measure of 265 degrees. Now, if we continue with part of this problem that we worked on last time, it's asking us to find each of the given arc measures. Now, there's a couple of different ways you could do this. One way is that we could say that we see that we have this angle and these arcs form a line, so they should add to 180. So x plus 55 should add to equal 180. And if I solved, you would get that x equals 125. So I can fill in that this arc is 125. Now from there, we could potentially use vertical angles because we have that these two diameters form straight lines and are straight across from each other, giving us that this angle is 55. Now we have all the angles except for this last angle over here, and we know that all the angles in a circle, or all the arcs, always add to 360. So you could say that 125 plus 55 plus y plus 35 plus 55 should equal 360. And if I solved to 360, well, we can combine our like terms. So you'd have 270 plus y equals 360, And then if we solve, you'd end up getting that y equals 90. Now let's say I decided to approach it differently. So a different approach could potentially be, if I erase what I have here, is let's say I decide to start with the fact that these angles form a line, and I call this x. I could say that 55 plus x plus 35 should equal 180. And if you solve, you get that x equals 90. Now let's say I continue to use this sort of strategy. So if I erase this part, now let's say I choose to use that these angles form a line. So I'd have, and I call this y. So you could say 90 plus 35 plus y equals 180. So if I solved, you'd have that y equals 55. And then lastly, I now know everything except for this last angle. So what I could do is I could say all the angles in a circle add to 360. So z plus 55 plus 90 plus 35 plus 55 should equal 360. And if I combine my terms, I get that z plus 235 equals 360. And then if I subtract the 360 minus 235, it gives you that z equals 125. So I have that this arc is 125. Now, regardless of which method we have, I can now use the fact that this arc is 125, this arc is 55, this arc is 90, this arc is 35, and this arc is 55. So now erasing my work, so I'm just focusing on the problems. We first have that it's asking for the measure of arc CD. And if I look at the problem, and if I look at what's given to me, arc CD is referring to just this piece right here. So arc CD will be equal to 55 degrees. Now for my next problem, it's asking for the measure of arc CGD. So I would start at C, go around to G, and then back over to D. So I can draw it in, start at C, go around to G, and then over to D. Now, using this, we could do one of two things. You could either add all the angles, or you could do 360 minus the part that's not included. And the part that's not included here is this 55. So we could treat it as 360 minus 55, which gives us a value of 305. Now for the next example, it asks for the length of AC, which is just this part. And I know that from what's given, AC equals 125 degrees. The next problem asks for arc ACF. So I would start at A, go around to C, and keep going to F. So we could either add all the angles, or do 360 minus 55 minus 35, since they're not included. But regardless of which way you do it, it'll give you an answer of 270. And the last example we have for this problem asks us for the measure of arc ACD. So we would start at A, go over to C, and back around to D, but we previously identified that this is a semicircle, which means that the measure of the arc is automatically 180 degrees. So as you can see, these sort of problems are sometimes time consuming, but once you decide on an approach, you can approach it however you want. There's a lot of different ways to get to the correct answer. Our next example just asks us to find the measure of the arcs. So if we start by indicating what we know, so since this arc is 40, the central angle is 40, and since this arc is 56, the intercepted arc is also 56. Now, the first part is asking us for the measure of YM. So this arc. Now we'll notice if we were to combine all of these arcs together, we could add them all up. Then they should equal 180. So you say x plus 40 plus 56 should equal 180. And if we solved, we'd have 180 minus 40 minus 56 should give you that x equals 84. Which means that this arc should equal 84. If I erase the extra blue I have here, this arc should also equal 84. So arc YM equals 84 degrees. The next part asks us for the measure of arc DXM. So we're going to start at D, go through X, and then keep going all the way around to M. Now we could find those small angles and determine what they are. However, we can see that arc DXM is a full circle excluding this piece over here. So if I were to write this as an equation, I could say that arc DXM plus the 40 plus the 84 should equal 360. So if I solved, it should give us that arc DXM by subtracting the 40 and subtracting the 84, you would get that the measure of the arc equals 236 degrees. And again, this is just one possible way of doing this. Now, our last few examples is going to require us to solve an equation. Now, based on what we know, if we have, this is an arc, and this is the intercepted angle that intercepts that arc. And since this arc intercepts the angle, the 10x plus 7 should equal the 57. So if I wanted to solve, I could subtract both by 7. So you'd have 10x equals 50, and then divide by 10. So you'd have x equals 5 as your final answer. Now for our next example, since we have that this arc is 72, I know that the central angle is also 72. And since the arc is 11x minus 1, this central angle is also 11x minus 1. And since these angles all combine to form a line, we know that they should add to equal 180. So you could say that 72 plus 43 plus 11x minus 1 should equal 180. So if you simplified, you'd have 11x minus or plus 114 should equal 180. So you'd have 11x equals 66. So x equals 6 as your final answer. And then for our last problem we have here, we could say since this angle is 115, the essential angle is 115, and since this angle is 67, 65, we could say this is also 65 degrees, which will allow us to do one of two things. We could either write an equation using the fact that these all add to 180, so 6x plus 4x plus 5 plus 65 equals 180, and then you could solve. The other method you could do is that if we find this arc over here, since these form a line, we could say that we'll call it A plus 115 equals 180. So we get A equals 65. And then if I know this is 65, we know that all the angles or arcs in a circle add to 360. So we could say that 65 plus 6x plus 4x plus 5 plus 65 plus 115 should add to equal 360. Either way you decide to solve, you'll get to a scenario where you'll have x equals 11. So again, the first one's option 1, option 2, whichever you choose to do, it's up to you and how you see the problem.